And so what do we need? Oops, what do we need here? So minimum requirements for graphing. For graphing polynomials. I suggest you start out the same way every time. The first thing that you need is the end behavior. That is going to be about the plus or minus lead term. That's what you need. The next thing you need are the zeros and their multiplicity. You can't spell. Multiplicity. And then the last thing that you're probably going to need is the y-intercept. And that's it. And you can graph some simple polynomials. So let's see. Do I have any more good examples? Let me find one out of the book. We'll take care of that, and then we'll have another break. Let's see. I guess this is example 5. Graph f of x equals x cubed times x plus 2 squared. This is number 15 in your homework. Okay. So one thing that you might want to do is determine what the degree is. And that might be a simple matter of you multiplying this out correctly. So let's see. When we multiply this out, this is x cubed times x squared plus 4x plus 4, which is x to the 5th plus 4x to the 4th plus 4x cubed. And the reason I multiplied that out was so that I could look at my leading term. So this is the lead term. The degree here is 5. It's odd. That's the highest occurring power of x. And the lead coefficient is a equals 1, or I guess a sub 5 equals 1. And so that's enough to tell me what the end behavior is right there. So my end behavior is positive odd end behavior, which means that it is up in quadrant 1 and down in quadrant 3, or as x approaches positive infinity, f of x approaches positive infinity, and as x approaches negative infinity, f of x approaches negative infinity. And so there's my end behavior. So I guess that's step 1. Step 2, I need the zeros and their multiplicities. That is going to come from this factored form. So let me grab that. I'm going to actually rewrite that. Some people have a hard time with this because of that x cubed. So it might help if you rewrote this as x minus 0 quantity cubed and x plus 2 squared. And that will equal 0. So we're trying to find our zeros here. That'll equal 0 if x minus 0 equals 0, or x plus 2 is equal to 0, in which case x is 0, or x is negative 2. But according to what we have here, we have our multiplicities. And so this is with multiplicity 3, and this is with multiplicity 2. So now we can start putting this information together. The last thing that we might want, though, is our y-intercept, and that's simply a matter of plugging in 0, and that'll give us 0 cubed times 0 plus 2 squared if we used our function, and that is just 0. So this curve definitely goes through the origin, and we start to put all this information together. as follows. Doesn't need to be that big. Let's see. The end behavior is as follows. So it has to go down in quadrant 3 and up in quadrant 1, or as x approaches positive infinity, the y values approach positive infinity. And as x approaches negative infinity, the y values approach negative infinity. Y versus x axis here. We do know what our zeros are. Our zeros are -2 and 0. So let's see, that'll be -1, -2. And I have a 0 there and a 0 here. And then, of course, we have our behavior near those zeros according to their multiplicity. And so at 0, it's a multiplicity of 3, which means it's going to be the snake. And so if this is our end behavior, this has to go up in this direction, but it has to come through this 0, get really flat, and snake through. So it's got that snaky behavior, very snaky. It's then going to have to, at some point, turn around. And then when it gets to this 0 here at -2, it's got a multiplicity of 2, so it's going to have some parabolic behavior, or behave like a parabola. And then, of course, continue on down in this direction. So that is what this curve looks like. This is f of x is equal to x cubed times x plus 2 squared. And there's an example. And when I grade this, I'm not really interested in how far down this goes. You know, you could have had some really different looking curves here in terms of scale. Some of you might have drawn something that looks like this. Whatever. Or, you know, it could have been really, really shallow. Maybe I shouldn't have done it that color. Let's see. Whoops. Or this could have been done really, really shallow. But regardless of how you draw it, when I grade it, I'm grading you on those 3 things. Do you have the right end behavior? Do you have the right zeros with their multiplicities and behavior? And then, of course, do you have the correct y-intercept? So regardless if your curvature is a little bit different, it should be a smooth curve through those features, but it should have those defining features. So again, this is what you're being graded on. What's your y-intercept? What are your zeros and the correct behavior near those zeros? And then, of course, the end behavior. That's what I'm grading you on.